A line capital AB has its end A 20 mm above HP and 30 mm in front of VB. The other end B is 60 mm above HP and 45 mm in front of VB. The distance between the end projectors is 70 mm. Draw its projections. Determine the true length and apparent inclinations. So here, a line end A is 20 mm above HP. So when you look from the front view, the distance above HP is seen. When it is projected, the image will going to fall on the vertical plane. So the distance above HP is seen in vertical plane. So this becomes A dash. Similarly, and 30 mm in front of VP. When you look from the top view, the distance in front of VP is seen, and when it is projected, it will going to fall on the horizontal plane. So this point will going to become small a. So the distance in front of VP is seen in HP. So this point will going to be small a. Next, the other end B is 60 mm above HP. The 60 mm above HP, when you look from the front view, you can see that distance of 60 mm above HP is seen in vertical plane. So when it is projected, it will be seen in the vertical plane, and then you draw a dash dot line which will be the locus of B in the front view. Similarly, and 45 mm in front of VP. In front of VP is this distance, that is from here to here, which is in front of VP. So that distance, when it is projected, it will going to fall on the vertical horizontal plane, and that distance is marked with the dash dot line, which will going to be again the locus of B in the top view. Now, the distance between the end projectors is 70 mm. So we have a projector A, which is from A dash, from here to here. This is the distance of the projector A, which will be 20 mm above HP, and from here he says the distance is 70 mm, the projector of B. So from here, when you look from the front view, the distance between the end projector of the point B will going to be lies on the vertical plane. So from here you draw a 70 mm line, and then project this in the vertical plane, so that the distance will go into that line will going to cut the locus of B in the front view at this point, which will be B dash. Similarly, the distance between the end projectors in the top view is 70 mm. From here you measure the distance of 70 mm and draw a vertical line such that it will going to cut the locus of B in the top view, and you mark that point as small b. Then join A dash to B dash with a dark line, and also A to B with a dark line. So this will going to be the top view, and this will going to be the front view. So when this is projected from here to here and also from here to here, this is the point wherein you will going to get the actual line capital A and B with a, that is then represented with a blue dark line. Now, so we know the front view of the line and we know the top view of the line. That is basically because we know that this is the front view. This is because the top view line is inclined. We know that this is the top view because the front view line is inclined. Now what is the requirement is that determine the true length and apparent inclinations. So that means we need to find out alpha and beta and also the true length. Now first we will going to find the true length in the vertical plane. If you want to find the true length in the vertical plane, we need to make one of the lines, that is the the line which is inclined to VP, you have to make that line parallel to VP. Then only we can find the true length in the vertical plane. So with A as center, take the radius of AB, which is the capital AB, which is in space. When it is rotated such that the B will going to be in front of VP by 30 mm. But actually this point B, which is in front of VP by 45 mm, you rotate it such that B will be also in front of VP by 30 mm. Since we have changed the position of point B, which was at 45 mm, is made to be in front of VP by 30 mm, then that point will going to become B1. And when it is projected onto the horizontal plane, this will going to lie at this point. So AB1 will be made parallel to VP. So when it is rotated in space, that is from B to B1, similarly in the horizontal plane, when it is viewed from the top view, which will be moved from small b to B1, so that both A and small b1 will be in front of VP by 30 mm. When it is in front of VP by 30 mm, then that line, that is capital AB1, will going to be in the true length. And when it is viewed from the front view, the image will going to fall on the vertical plane. So A dash B1 dash will be in true length, and you join A dash, then join A dash to B1 dash with a little bit thicker than the projector line. So when it is parallel, when you are projecting, means the image will going to be that the line will be drawn from B1 to the intersection of XY line, and again from here you draw a vertical projector which will going to cut the locus of B in the front view, which is B1 dash, and this will going to be the true length in the vertical plane. So similarly, we need to find out the true length in the horizontal plane. So when you want to find the true length in the horizontal plane, so we have to rotate the front view point such that the line which is inclined to HP, you make that line parallel to HP. So how to do that? With capital A as center, you take the radius of capital AB, then rotate it such that the B, which was above HP by 60 mm, is made to be above HP by 20 mm. So that means that capital B is moved from B to B2, capital B2, such that B2 will be above HP by 20 mm, and capital A is also above HP by 20 mm. Then capital AB2 is the line which is parallel to HP. When it is parallel to HP, so we will be able to find the true length in HP. So when it is projected, this will going to fall on the locus of B in the top view. Then that point will going to become small b2. Since it is parallel to HP, so we have got capital A and capital B2 on the locus of B. Then join small a to B2 with a little bit thicker than the projector. So while doing so, what happens is the image will be in the front view. That means with A dash as center, take the radius of A dash B dash, and you have rotated such that A dash B2 dash will be above HP by 20 mm. Then that line will be parallel to HP. So when this is projected here, so that line will going to be the parallel to HP. Since it is parallel to HP, and then when you projected that onto the top view, you will going to get this point small AB2. So this will be the true length in HP. Now, so this is how we can analyze. Then we can find out the apparent inclination with respect to HP, which is alpha, and then apparent inclination with respect to VP, then it becomes beta. So we will going to find the true length in the top view also. So this is how we can analyze the problem in 3 dimensions. Now we will going to solve the problem by using the sketchbook. First, we will going to draw the XY line and mark vertical VP and HP, which is as shown. Now, end A is 20 mm above HP and 30 mm in front of VP. So from the xy line, the distance above HP is seen in vertical plane since the vertical plane is above xy line. So from xy line, you measure the distance of 20 mm and draw a horizontal line. Then 30 mm in front of VP. In front of VP is seen in HP. So HP is below xy line. From the xy line, you measure the distance of 30 mm and draw a horizontal line. Consider any point and draw a vertical projector which will going to cut both the lines at A dash and small a in front view and the top view respectively. Then the other end B is 60 mm above HV and 45 mm in front of VP. So from XY line you measure 60 mm above XY line and draw a dashed dot line which will going to be the locus of B in the front view, and 45 mm in front of VP, and from XY line you measure the distance of 45 mm below XY line and draw a dashed dot line. Again you write locus of B in the top view. Now he says that the distance between the end projectors is 70 mm. So from the vertical projector of A dash and A, you draw a horizontal distance. You measure a horizontal distance of 70 mm and draw a vertical projector. This projector will going to cut the locus of B in the front view at this point. You mark that point as B dash, and similarly in the top view at B. So then join A to B with a dark line and A dash B dash with a dark line. So now this is the front view. So that means the top view line is inclined. So this is the top view because the front view line is inclined. Now first we will going to find out the true length in the vertical plane. So to find out the true length in the vertical plane, the line should be parallel to VP, then only that line will be in true length in the vertical plane. So first, to find out the true length in the vertical plane, you have to make the line which is inclined to VP has to be parallel to VP. So which is the line which is inclined to VP? The top view line is the one which is inclined to VP. So you make that line parallel to VP. So with A as center, by taking the compass, measure a distance of AB and then draw a arc such that both A and B1 will be in front of VP by 30 mm. So then AB1 is the line which is parallel to VP. Since AB1 is the line which is parallel to VP, when it is projected, so you're going to get the true length in VP. So from B1 you draw a vertical projector to the front view such that it will going to cut the locus of B in the front view. So this point will going to become B1 dash. Then join A dash to B1 dash with a little bit thicker than the projector line. So this will be A dash B1 dash will be the true length because AB1 is parallel to VP. So you write this as capital A and capital B here. Now similarly we need to find out the true length in HP. Since we want to find out the true length in HP, so line has to be parallel to HP. So in order to make the line parallel to HP, you have to take the line which is inclined to HP. The line which is inclined to HP is A dash B dash. So this line has to be made parallel to HP. So with A dash as center, take the radius of A dash B dash. You draw an arc such that both A dash and B2 dash will be above HP by 20 mm. Then since A dash B2 dash is parallel to HP, so we will be able to find the true length in HP. The true length in HP can be found in the top view. So draw a top view for A dash B2 dash. With A, draw a vertical projector from B2 dash to the top view, wherein it will going to cut the locus of B in the top view. Then mark this point as B2. Then join A to B2 with a little bit thicker than the projector line. So this will going to be the true length in HP. And since he finds the apparent inclinations and the true length, so you measure the true length of A to B2 and find out that value. By using the scale, you measure the distance from A to B2, which will be, true length will be 82 mm exact. So similarly, the true length is same in both front view and same top view. And also, by using the protractor, you measure an inclination of apparent inclination, that is the front view line inclination by using the protractor, and mark that point, mark that angle as alpha, where alpha is 29.474 degrees. when you are doing it in computer. When you are doing it in manual, it will be 30 degrees. Similarly, you measure the top view inclination, that is AB, with respect to the horizontal line by using the protractor, so that the angle will be shown as beta. So it will be 12.09 when you are doing it in computer. When you are doing it in manual, it will be 12 degrees. So this is how we can be able to solve this problem in the sketchbook. Now the same thing which we have been explained in the stepwise. So here first we have considered the front view. First we have measured, first we have projected all these with both the distance above HP and in front of VP of the line end A and also the end B. Then drawn the horizontal projector with respect to the projector A and with the projector B. Then we got small AB in the top view and also A dash B dash in the front view, because both the end projectors will go into cut the locuses. So the corresponding locuses here, A dash and A is the one point which is going to be on the locus. Similarly, B dash and B is the other locus. Now we are finding out the true length in VP, so you are making the line parallel to VP, and we have projected this, so you are going to get that A dash B1 dash, which will going to be the true length in VP. That is what we have explained here. We have rotated this the line which is in space AB, and we have rotated that B such that AB1, capital AB1 will be parallel to VP, so you are getting the true length in VP. So this is find out the true length and the alpha inclination in the front view. Similarly, now we are considering the front view line. We are considering the front view line which is A dash B dash, and then when it is rotated such that it will made parallel to HP. So accordingly we will be able to find the true length in HP. So in 3 dimension you can see that the line which is in space AB, when it is rotated such that both A and B2 will be above HP by 20 mm, then that line will be parallel to HP, so we can find the true length in HP, that is capital AB2 or small AB2. So that is what we have done here in the orthographic view also. So we have rotated A dash B dash such that both A dash B2 dash will be above HP by 20 mm. Then when it is projected, then the top view of this line will going to become the true length, which will be AB2. And find out the inclination beta, which is the top view inclination with respect to VP. So which will be 12.09 or 12 mm. So this is how we can be able to solve this problem in stepwise also.